Hello rail fans, welcome back to the Train Zone once again. Thanks for tuning in. I have another switch repair video. These are O27 K-line switches. They have the LED, the later version. The 42-inch remote switches would be a 275 and a 276, and then these 27-inch path would be 265 and 266, I believe. And I'm going to show you some repair here the first couple minutes, and these work really well. I've had a few problems with them, but they're pretty easy to repair so far. I've seen one controller go bad that I couldn't repair because I'm not an electronics specialist. You can see why I would rather have this wider turn 42-inch manual switch converted into a remote switch. So I'm going to take the parts off of this remote switch because I don't use any 27-inch turns. They're just too sharp. First thing, if you have a switch that's not working very well, under here, see, I've cannibalized this one. I already took the goodies off it. This was a remote switch. This is under there, and you can't just tighten up the nut on the bottom because it's also, the screw is threading inside of this centerpiece is a nut also. Oh. So tightening up the nut only does half of it. This thing's too tight. There we go. See, it threads in that piece also, as well as the nut threads on the other end of it. So you got to make sure both ends are tight. Tighten the Phillips side first, then tighten the nut on the bottom. And that's accessible without taking the cover off. Here's the cover, so it'll look like this. You can tighten the nut secondary after you already tightened the screw. The next thing to look at on this one, they didn't solder. So you can see these. You see on this one they soldered these connections here, but on this one they didn't. So you can solder this stuff, all of them, and then on the other side, where it's getting the ground, solder it in here, and then the track power, you're making sure that's soldered, and then also solder it here. That's the next thing to look at. I've done a number of these conversions. I had a number of remote O27 path switches and then a number of manual 42-inch path switches. So here's some of the parts. As you can see, there's no switch motors in here. The motor would lay in here, but it has the micro switch and the circuit board and similar gears. There's a little clip holding this micro switch together. And on a couple switches that didn't work, this was cracked, so the switch was hanging down, and then the action wasn't working the switch correctly. So what I did to fix it is I had held this up, put some super glue along this edge, and glued that, and it repaired it. Because it just needs that little bit of action to move that little lever in there. And as you can see, the insides are mostly the same on these, but the housings are different. One was a right, one was a left. These things come out different sides. Alright. One more thing to show you on these. So I cannibalized some of these off of here. I wanted to tear them off of there just in case I needed those lugs. The wiring is different on some of these. The ground is the furthest one over going to this rail on this design. Here the ground was here going to this wire, and you can see this is more of a messy design than this, which I believe this is the later design. And then lining up, turn it around, I don't think you'll be able to see it. There's a little square here for ground, and there's a little square here, ground. So on the newer one with this, the ground was here, ground there on the sloppier one. So I wanted to show you those differences. Now the lugs that I'm going to put in here into this guy, just got some screws at the hardware store. Digikey.com is where the gentleman that I got this stuff from, he said that he was able to pick these lugs up from there. They're pretty inexpensive, and like I say, the fasteners, these things are just a little hardware store, nuts and bolts, and then these little solder terminal lugs. There's the screws from the back, threaded post nuts. Alright, let's get going on this thing. I've written out already my wiring diagram, the schematic here. Track power, the red, yellow, these are the insulated rails, yellow and blue. These, I believe, are diodes, so we got to keep the polarity correct. I've marked one end of these with the black marker, and the green. So I need to cut this, because these need to be insulated rails, and this is the manual switch. So I need to cut this metal, separate that, remove these items out of here, pull the LED assembly out of there, and then I'll show you the next step. Another problem you could be having inside of your switch track is, you can see this wire wasn't even soldered correctly. It was a cold solder joint, a big blob of solder right there. It didn't even soak into the wires, and this was like it. This thing looked to be a new switch to me. There's no black tracking from the center roller, no wheel tracking. This one wasn't in a box when I got it, but it definitely had a failed solder joint. I want to show you the progress here on our conversion of the manual switch to remote on this 42-inch path switch. Remember the metal bands that were providing the continuity between these outer rails here for better ground, but we needed to cut these bands of metal out so our inner rails would be the control rails for the non-derailing feature. So I cut those out and installing the wires. You know, we drew out the schematic, the original wiring on the switch that we took these parts from. I have my diodes soldered in here. I had to put in a jumper wire to make it a little longer. That's a ground rail. And I had to put in a little jumper wire here. And we have the terminal studs installed. Pretty fancy. It's looking good. And then the switch motor wires, I didn't install them yet. I wanted to show you the difference. We had looked at the manual switch gear housing, so this one has a motor inside of it, so you can see the difference. This screw is stripped out, so I put some glue down in there and put the screw back in. Everything else seems fine. This micro switch seems fine. The circuit boards appear similar. There's an extra red wire here going to the switch motor, and let's see, the white wire down there, that looks the same. The brown wire looks the same. Of course, there's extra wires here. So there's a difference in the circuit boards too, it looks like. And I thought of some extra tips for you if your switch isn't working right. If your lights aren't right on your controller, but it's still working, the controllers are stamped right hand for the right hand switch or left hand for the left hand switch. And I have tried a left hand switch controller with the right hand switch, and it works. It's just the lights, the LEDs, are lit up incorrectly. One more thing, if your switch isn't working at all, let's say the LEDs aren't lighting up, with track power going to this stud on all the remote switches of this design that I've seen, I don't know if you can see it, these two are labeled track. Here's an F for fixed. If you're running off a track power and it comes from the center rail and you don't have a wire here from a accessory terminal or a spare transformer to run off a fixed voltage, you need to have a connector between these two so that the track power from here can get to this terminal where you would otherwise have fixed voltage. And then that is connected here, and then with the red wire also on the switch motor, these are both going to go to that R terminal. So that's how your switch is getting power. And originally there's a flat piece of metal that comes with these switches, but if you can find these used, and these switches are hard to find, but they might be missing that flat piece of metal, so just strip off some wire and connect these two terminals together and see if that makes your switch work. If you've already soldered the connections, the ground like I was telling you, and then I'm going to solder this right here because it's soldered under here, but it's only crimped here, so I'm eventually going to solder that too. Alright folks, here is the finished product. She's a beauty. A remote controlled 42-inch path switch, working now because of the parts donated from the 27-inch path switch. Soldered there for that ground connection, soldered there for the power connection if we were going to use track power, and remember we have to bridge those two together. Here's the finished product. It's just beautiful, isn't it? It doesn't have all the metal printed circuit boards kind of thing, you know, like the original had. And I don't know if I told you, you can see the lines, the molding in the plastic where I drew the black lines. You can see that in the plastic where the routing was anyway. So let's see if it's going to work. So if I'm going to hook the power here, remember I need to bridge these two. So I'm going to go straight to fixed power because I'm not putting a piece of wire there. Our automatic non-derailing feature. And with this being ground, we can run the switch this way for this test purpose here. I'll hook up the controller. One more thing to note, if you have one of these, this is, you know, a right hand controller for the right hand switch. It's stamped right hand, and it has these white lines, as you can see on this wire. You know, right off the top of my head I would think, oh well, that would just go to ground and then one of these would be right and left. But on this switch right here that I have, that's not the case. We have those lines right here. Here's GR for ground. So it goes to the inner control rail right here, is how it was set up. So I believe that controller did come with this switch. None of the other ones have these white lines on it. And this is that mutant switch with the posts in a different order than the rest of them that I have. And maybe it's the earlier design. So with this wire hooked up to where it's going to this control rail and then putting these in a row, look what happens when I turn on the power. Both lights are lit up on the controller and it doesn't work. So if I reverse the wires down here, just like the studs are reversed, the posts are reversed on these two switch tracks, then we're going to see this thing work. So keep that in mind too. There's definitely some different production runs of these. This is a real low voltage. That's like 6 volts. This is closer to 10 or 11. I have had some that at this higher voltage, when the switch hit, it kind of bounces back to a dead spot. And that can be irritating. See if I can get this one to do it. Sometimes when they hit and bounce back, it's at a dead spot. Like that. This one works really well. Yeah, I'll run mine, this old transformer, I run mine at about this voltage, less than half. I'll run them about here so they don't do that. Because I have a few, I've probably 24 of these switches. I've been able to find a lot of them. They're really hard to find. Keep looking on eBay. I'm not going to buy any more, so you guys can have them. Look at that. That's a little low. I run it a little higher than that. Right about here. Because I do have a few that like to bounce back. Here's the finished product with the back on it. Nice and shiny. It fits a little wide there with those bigger screws under there because the factory studs are riveted on. That's another thing you could check if stuff's not working. If any of these are ever loose, you need to solder it in there. You'll probably melt your plastic a little bit, but the soldering it is gonna make it a lot tighter, and you can bend the stud into the melted plastic and straighten it up if it melts a little bit. My screw was not very tight, so I loosened the nut, tightened the screw down onto that center nut in the middle like I was telling you about, and it has the insulated washer in there, and then you tighten the nut up last. So here she is. What a beauty. Took some work. Took me, gosh, at least an hour and a half to do this, it seems like. But a 42-inch path switch. Hope you guys learned something, and as always, thanks for tuning into the Train Zone. Happy railroading.